Hi everybody, Mrs. Pesic here. We're going over the 4.9 Quizlet. I'm going to be going over version A and B. So if you had version A, you get to see a little bit more practice problems by looking at some of the ones from version B and vice versa. So let's start with number 1. We see that we're supposed to find various values here. And we notice, first of all, what's marked congruent. Segment DE is congruent to segment EF. I'm sorry, DE is congruent to DF. So that makes those two sides congruent, which means that this must be the base. And this would be a base angle, and this would be a base angle, and those two angles would have to be congruent. So in this case, we know that this angle here is 3x, so this angle here has to be 3x also. So by the triangle sum theorem, 42 plus 3x plus 3x is going to have to add up to 180. All right, first of all, lots of people thought that 42 was going to be congruent to 3x, but those are not congruent, those are not the base angles. All right, so when we solve this, we get 42 plus 6x equals 180. Subtract 42 from both sides, and you get 6x equaling 138. And then if you divide both sides by 6, you end up getting x equals 23. So x is equal to 23, and now we can plug those values in to find angle E. So 3 times 23 gives us 69, and that's going to be the measure of angle E, and it's also going to be the measure of angle F. All right, let's take a look at the similar problem from version B. Maybe you had this version. And so in this case, we're trying to find x here, and we can see that, again, segment DE is marked congruent to DF. So that means that this angle and this angle must be congruent. Right? The angles across from the congruent sides are going to be congruent. So that means this angle here must be 4x also. So we get 36 plus 4x plus 4x has to add up to 180. So 36 plus 8x equals 180. And we subtract 36 from both sides. And we get 8x equaling 144. And we divide both sides by 8. And we get x equaling 18. So if x is equal to 18, we can fill in 18 for x here, and we get 4 times 18 is equal to 72. So that's 72, and this one's going to have to be 72. And as a check, if I add 72, 72, and 36, because those are the three angles of my triangle, they should add up to 180.
Miss McGinty, please call extension 1100.
Let's take a look at number 2. This time we see a triangle that is equiangular. It has 3 congruent angles. And if it's equiangular, that means it's going to be equilateral, meaning the 3 sides are going to be congruent. So that means that 8 minus 4w has to equal 2w plus 5. And so when we look at this was number 2 from version A. When we look at this, we can solve this by adding 4w to both sides. And
If anyone has found a Samsung 7
subtracting 5 from both sides.
We ask that you please bring it to the office.
So we get
or call extension 1100.
We get 3 equals 6w. And so we divide both sides by 6, and we get w equaling 1/2. It's okay to have fractions as your variables. And so if w is equal to 1/2, can we find the length of each of these sides, RT and RS? So if I plug in 1/2 for w, I get 8 minus 4 times 1/2. That's going to be 8 minus 2, which is going to be 6. I hope we get the same thing when we plug in 1/2 here. So we're going to get 2 times 1/2 plus 5, and we get 1 plus 5, which is 6 also. All right, let's take a look at the similar problem from version B. This time, again, we see we have an equiangular triangle. All three angles are marked congruent, which means that the three sides have to be congruent. It means it's an equilateral triangle. So 2w plus 14 has to equal 12w plus 17. And to solve this, we might want to subtract 2w from both sides and maybe subtract 17 from both sides. So when we do that, we would get, let's see, we get 10w equaling, oh, my bad. You're like, what is she doing? Well, that's because she's writing down the wrong equation. I didn't copy it carefully. It's 24w plus 14 equaling 12w plus 17. Sorry about that. And so let's subtract 12w from both sides. And let's subtract 14 from both sides. So we'll end up getting 12w on the left and 3 on the right. And when we solve this, we're going to divide both sides by 12, and we get w equals 1/4. So w is equal to 1/4. So now to find our t, we're going to plug in 1/4 for our w. So 24 times 1/4 plus 14, we get 24 times 1/4 is 6. 6 plus 14 gives us 20 for the length of our t. And then if I plug in 1/4 here, I get 12 times 1/4 plus 17. That's going to be 3 plus 17 is also equal to 20. Let's take a look at number 3 from version A. For number 3, it shows the triangle with all three sides marked congruent, which means it's an equilateral triangle. But all equilateral triangles are also equiangular, which means all three angles are going to be congruent. And if three angles in a triangle are congruent, and the three angles add up to 180, that means that each one has to be 60 degrees. So that's 60, this is 60, this is 60 degrees. So this angle M, which is represented by 45 minus 3x, must equal 60. So to solve this, we might add 3x to both sides and subtract 60 from both sides. And so here we're going to get, let's see, I'm going to get negative 15 equals 3x, and divide by 3 to both sides, and I get x equals negative 5. Is it okay for x to be negative? Sure. Let's see what happens if we plug in negative 5 right here for x. I'll get 45 minus 3 times a negative 5. That's 45 plus a negative 3 times a negative 5, so that's plus positive 15. And sure enough, that gets us to 60 degrees. Let's take a look at the similar problem from quiz B. In this case, again, we see that the three sides are marked congruent, which means it's an equilateral triangle, and that means it's going to be equiangular, so all of these angles are going to be congruent. And if they're all congruent, that means that each one of them is going to measure 60 degrees. So that one's 60, that one's 60, and this one right here is going to measure 60 degrees as well. So let's set 12 minus 6x equal to 60. And if we subtract 12 from both sides, we get negative 6x equals 48. And then we divide both sides by a negative 6. We would get x equals negative 8. All right, and if I'm going really fast on this video, feel free to stop, pause, rewind. All right, so x is equal to negative 8, and then the measure of angle M, hopefully it's going to be 60, but let's check to make sure we did it correctly. It's going to be 12 minus 6 times a negative 8. That change that minus to plus a negative, so it's 12 plus negative 6 times negative 8 is a positive 48. So we do get 60 for the measure of angle M. Let's take a look at number 4 from version A. So on this one, we see the given information is that segment AB is congruent to segment BC. Those two sides are congruent, which means that the base angles have to be congruent. It's an isosceles triangle, and that's the isosceles triangle theorem. So that means that 3x plus 5 has to equal 6x minus 10. Solving this equation, we could maybe subtract 3x from both sides and maybe add 10 to both sides. So we'll get 15 equals 3x, divide both sides by 3, and we get x equals 5. Now that we know that x is equal to 5, we can find the measure of angle A. We're going to plug in 5 right here, so we get 3 times 5 plus 5. That's 15 plus 5, and that's going to give us 20. Now it's asking for measure of angle B. Well, let's leave that one for right now. And let's go on and do this one, measure of angle C. If we plug in 5 here for this x, we get 6 times 5 minus 10. That's 30 minus 10 is equal to 20. Well, that's good because angle A and angle C are supposed to be congruent. Now, if you want to find this angle up top, measure of angle B, we know the triangle sum theorem says that the three angles have to add up to 180. So what's 20 plus 20 plus measure of angle B? Well, that has to all add up to 180. So we get 40 plus the measure of angle B is equal to 180. We can subtract 40 from both sides, and we get that the measure of angle B is equal to 140. So that's our answer for this one. So altogether, this is 20 degrees, and 140 up on top. Let's try that similar problem on version B. In this case, again, we see segment AB is congruent to segment BC. Those are marked, which means it's an isosceles triangle. That means the base angles have to be congruent. The sides opposite those congruent sides are congruent. The angles opposite the congruent sides are congruent. Hopefully I'm saying that right. And so that means that 4x plus 1 has to equal 6x minus 11. And we're solving. Let's subtract 4x from both sides. And let's add 11 to both sides. So on the left side we get 12, and on the right side we get 2x. Dividing both sides by 2, we get x equals 6. So we know x is equal to 6, so we can plug 6 in to find measure of angle A. So if we do that, we're going to have 4 times 6 plus 1. That's 24 plus 1 is 25. Let's skip over and find measure of angle C. Again, we're going to plug in 6. So we get 6 times 6 minus 11. That's 36 minus 11, which is also 25. Remember, that's measure of angle C. And to find measure of angle B up top, we will need to say 25 plus 25 plus measure of angle B is equal to 180. So we get 50 plus measure of angle B equals 180. And we're going to subtract 50 from both sides. And we are going to get that the measure of angle B is equal to 130. So that should be our answer for the measure of angle B. Do these three sides add up to 180? You betcha. All right, let's take a look at number 5 from version A. On this version, we see again that we have an isosceles triangle. Segment DC has been marked congruent to segment CE. We also know that this angle is 2x and this angle is 5x, but they are not congruent because those are not the base angles. All right, 2x is going to have to be congruent to this angle over here because those are the two angles that are across from the two lines that are, the two segments that are congruent. So that means we can fill in 2x here for this angle. That's going to be 2x also. So our angles are really 2x, 2x, and 5x, and those three angles are going to have to add up to 180. So When we solve this, we end up getting 2x plus 2x is 4x plus 5x, that adds up to 9x equals 180. And then if we divide both sides by 9, we get x equals 20. So if x is equal to 20, then we can find the measure of angle C by filling in 20. 5 times 20 is 100. So that's the measure of angle C. And to find the measure of angle D, we can plug in 20 there, and we get 2 times 20 is 40. So that's 40. So that means angle D measures 40 degrees, angle E measures 40 degrees, and angle C measures 100 degrees. Do those add up to 180? You betcha. All right, let's take a look at number 5 from version B. Again, similar setup. We have segment DF congruent to segment EF. Well, what angle is across from DF? Well, that's angle E. What angle is across from EF? Well, that's angle D. So these are the two congruent angles, not the D and F, but D and E. So that means that this angle here must measure 7x also. So we see 7x plus 7x plus 22x has to add up to 180. And if we're solving this, these all add up to 36x. That's 7 plus 7 plus 22. So 36x has to equal 180. And we divide both sides by 36, and we get x equals 5. So if x is equal to 5, we can find the measure of angle F right here by plugging in 5, and we get 22 times 5, and that turns out to be 110. And to find the measure of angle D, we're going to plug in 5 here. 7 times 5 is equal to 35. And again, since D and E are congruent, this angle measures 35 degrees, and this angle measures 35 degrees, and this angle here measures 110. Do those three add up to 180? You betcha. All right, so that concludes this video as we went over the problems from the 4.9 Quizlet A and B. And I hope that you got something out of it. And if you have any questions, please let any one of us know. Thanks for watching.